Lesson 6.4 is a little bit deeper of a dig into exponential growth and decay. Growth is when something increases by the same factor over even time intervals. So it's growing in value like we'd want our bank account to. And decay decreases over even time intervals. This would be more like when you buy a car and drive it off the lot, it's going to decrease over time. So bank account increasing by 10% would go from 100 to 110. But then it wouldn't just go up to 120. 10% is now $11. So you'd be at 121. This is why exponential growth supports the whole idea that you should start saving for retirement as early as possible. And then decay is for something losing value. So decay fits something like the value of a car a little bit better. It'll never be zero or negative, but if I buy a $10,000 car and it's $8,500 next year, it lost $1,500 of value. It won't quite lose $1,500 again. Can't quite do that mental math just on the spot here, but it's going to change by a little bit less. So it makes this graph, whereas growth makes this graph. So this is what we want our bank account doing. This is what's going to happen to a car over time, or something that loses value after it's brand new. Here we have our equation forms. Let's compare this to what we learned in 6.3. The b value, the multiplier, can be two things depending on if it's growth or decay. This is growth because 1 plus r is going to imply that we're multiplying by a number that's going to make us bigger. 1 minus r implies that we're going to multiply by a fraction. We're going to lose a little bit each time. This is decay. All right? So the rate is not going to be exactly the number you see in parentheses. It's going to be how much above or below 1 it is. So the way to explain what the 1 is doing is 1 represents what I have right now. So if I did a times 1 to the t, let's say I start with $50 and my multiplier is 1. It doesn't matter how many years I go. Let's go 3 years out. I would multiply by 1 each time. 50 times 1 is 50, times 1 is 50, times 1 is 50. R is supposed to be the percent you change by. So if I make this 0.05, this represents a percent increase. So times 1.05 for 3 years. Again, not going to be able to do all this in my head, but 1.05, that should be, 1/20th of 50 should be $2.50. So 5% increase on this is going to be $52.50. And then we would do that 2 more times. I'd multiply by 1.05 again. It would increase by a little more. Then I'd multiply by 1.05 again. So 5 is actually the rate increase. All right. So the 1 represents what we had before. So how do we read an exponential growth or decay problem? The first year of attendance at a music festival was 150,000. A in our equation represents our initial value. What did we start at? Well, the first year was 150,000. The attendance increases. This tells us we're going to be working with growth by 8% each year. Now, we're not going to keep 8 as a percent. R equals, what's 8% is a decimal. Percent means out of 100. So if we divide by 100, we'll move that decimal place twice and we get 0.08. So 8% as a decimal is just 0.08. All right, now let's look at our growth equation. Y equals A. We found A is 150,000. Let me write that equation up here just so you know what I'm referencing. This was for growth. 1 plus R, since we're growing, to the t power. So then in my parentheses, it's going to be 1 plus 0.08, which I'm more than happy to just write as 1.08 to the t. T is going to represent the years that pass. So this is the answer to what is our exponential equation. For the 5th year, that's just our exponent. So we're going to multiply by 1.08 5 times. The problem in our notes wants us to round this to the nearest 1,000. So the answer would come out to 220,000. We had some hundreds. We had 399 here if you actually did it on a calculator, but the problem said to round. So in 5 years, we were going to have 220,000. So one other little thing, and this might just be a mistake with how I did this, but if we count this as the 1st year, the 5th year would only be 4 years later. 2, 3, 4, 5. If you answered this with a 4 and you read into the problem that way, you're also correct. So I'll try and make this a little more obvious when we do it on assessments, but yeah, honestly, this probably should have been a 4, not a 5. We got another problem here. Value of a car is $21,500. That's going to be our A value. That's what the car starts at. It loses, so we know we're using a decay function because we're losing value. So let's write that one up here. This time it's 1 minus R. So we have 12%. Well, 12%, again, divide by 100, which means move the decimal place twice. The R we're actually going to use is 0.12. So if I write out the equation, it's going to be y equals A, 21,500, times 1 minus 0.12. We can clean that up on our calculator. That's just 0.88. So it's a fraction. We're losing money, so a fraction makes sense here. And then T for the number of years. T for time. The value after 6 years, again, that just means 6 is our exponent. 0.88 to the T power. Money only goes to 2 decimal places, so that's where I'll stop at the end. I won't go any further than that. 21,500 times 0.88 to the 6th power. We end up with $9,984.69. All right. So the car is losing 12% each year. It's not going to lose 72% of its value. You don't just multiply this number up. The exponent will make it decrease like this. It'll lose the most in the 1st year, and then it'll lose a little less the year after that, and it kind of levels out. So it doesn't keep decreasing at the same rate. Okay, so that's an example of growth and an example of decay. Now let's look at a couple of tables. So growth or decay should be pretty easy to tell from a table, but we do want to check and make sure it's consistent because neither is an option. So let's see what's happening to y. 270 to 90, that's dividing by 3. 90 to 30, that's dividing by 3. 30 to 10, that's dividing by 3. This is decay. Dividing by 3 is the same as multiplying by 1/3. So this would have a fraction for its b value, the multiplier. 5 to 10, 10 to 20, 20 to 40, that's times 2, and times 2. This is growth, and its multiplier is 2. So exponential decay, exponential growth. Finally, we're going to look at equations. Equations, it should also be fairly easy to tell. We're either going to have a multiplier that increases our value or a multiplier that decreases our value. All right. So if you see like a y equals mx plus b equation, then you're going to see neither. So this is going to be growth because the multiplier is bigger than 1. But what's the percent rate? If I were going to read this in a word problem, what percent am I growing by? Well, this would be 1 plus 0.07. This is a 7% growth. You don't count the 1. The 1 counts the money we already have in there. How much more am I going to have after a year? 0.07 more. 0.07 as a percent is 7%. Same conversation over here. This is decay, which is 1 minus r. How much did I lose from 1? I lost 0.02, which means I made 2% decay. 7% growth over here, 7% more than 1, 2% decay over here, 2% less than 1. So 1 is status quo, 1 is if nothing changed, growth is anything bigger, decay is anything smaller for our multiplier. The number in front doesn't matter. That doesn't determine if we're growing. That's how much we started with. What determines if we're growing is what we're multiplying by repeatedly.